All right, welcome back, lecture 10B. So let's talk about pulse width modulation with this ECCP module. And so this is in your yellow data sheet, section 15 in the full data set data sheet. The main register we're going to work with is CCP1CON, the configuration register for compare, capture, and pulse width modulation. And there's a lot of words in here and a lot of details, but we don't need to worry about most of it. So here's what we're going to do. We are going to start with bits 3 through 0. We want to do pulse width modulation. And we're just going to have everything active high. So I said 75% duty cycle means your waveform is high for 75% of the time. That's what we call active high. So we're just going to make everything active high, which means these low 4 bits are going to be 1100. And that's going to do pulse width modulation. Everything is going to be active high. So these bits will be 1100. And not a whole lot of variation in that. Alright, the next 2 bits, if we're in pulse width modulation mode, these are extra significant bits that we can use to control the duty cycle. We're not going to be that fancy, so we can just set these to 0. And so that leaves us with these 2 bits, 7 and 6. And if we're in pulse width modulation mode, which we know we are because of these 2 bits, these 2 bits, 7 and 6, are interpreted in one of 4 ways. And we're just going to use this option here. We're going to use a single output on pin P1A, and we're going to leave these other PWM pins just as regular port pins. So we're going to set these to 0, 0. And our pulse width modulated output is going to appear on pin P1A. And if you look at the data sheet, that's pin 18. Alright, so we set this CCP1CON register up like this. Now CCP1CON builds on top of timer 2. Alright, so we don't need that. But we need to use timer 2, and we need to look at the PR2 register. So lots of details here. Let's not get bogged down in them. Basically, set up timer 2, okay, to generate an interrupt after a certain amount of time. That's going to be the period of your waveform. So suppose we want to generate a waveform that looks like this. It's going to go high and low. And suppose we want this to be 1 millisecond. Alright, this is driven by timer 2. So you need to look at timer 2, you need to set up the PR2 register, you need to set up the prescaler and the postscaler values and so on, so that timer 2 is generating an interrupt request after 1 millisecond. And we talked about how to do this in class, right, when we looked at timers. So that's nothing new, okay? That's just saying generate an interrupt at each of these time periods. How do we determine how long this waveform is on? Well, we use one other register, which is CCPR1L. And here's the basic setup. If you take CCPR1L and you divide by PR2 plus 1, that gives you your duty cycle. So let's say we want 1 millisecond period from a rising edge to a rising edge. And we figure out the value of PR2. So let's just say PR2 equals 99. Okay, hypothetically, this is what they use in the lab. So let's say PR2 equals 99. If we want a 50% duty cycle, we need CCPR1L over 99 plus 1 to be equal to 0.50. And do the math. This is 100, multiply through CCPR1L equals 100 times 0.5. That's just 50. Load the number 50 into CCPR1L, you got a 50% duty cycle. And in the lab, PR2 is set up to be exactly 99. So the duty cycle of this waveform is always CCPR1L over 100. So if you want a 75% duty cycle, put 75 into CCPR1L. If you want a 10% duty cycle, put the number 10 into CCPR1L. Okay, so that works out nicely because PR2 plus 1 is exactly 100. So you can thank Izad for making the math easier in this lab. Alright, so that's really all you need to do to generate pulse width modulated output automatically using this module. So what do? You set up CCP1con and you set it up in the standard way, right? Basically with 2 1s here, 0s everywhere else. You set up timer 2 in all the usual way. Use the T2 con register to turn on the timer, control the prescaler, and get that running, and then load a value into PR2 to determine the time from one rising edge to the next, so this time here. And then based on PR2 and what you want your duty cycle to be, use this formula to figure out what CCPR1L should be, load that in. Okay, once you do this, basically pin P1A, which is pin 18, starts doing this. Starts generating a high and a low and a high and a low with a period specified by PR2 and a duty cycle specified by CCPR1L over PR2 plus 1. Okay, so we'll go through the code in the lab in class, and we'll work out some examples of this in some homework problems on the board. But that's the basic setup, okay? Very simple in a lot of ways, but a lot of details. So if you look in your data sheet here, here's all the steps you have for setting up PWM. It's an entire page length. Don't get too bogged down in that. Okay, there's a lot of details that we're kind of skipping over and that we can get by without worrying too much about. But that's the basic setup. So we'll work with this in class, and we'll do some homework exercises, and then we'll use this extensively in the next lab. All right.